beautiful person, this is Anton, and today we're going to be discussing a discovery of a very intriguing terrestrial planet that was recently discovered using the TESS telescope at a distance of approximately 200 light-years away from planet Earth, but also a planet featuring quite a lot of unusual properties that both might help us explain certain things that we can't explain, but also presents a few mysteries we probably cannot explain just yet. So let's discuss this particular discovery in more detail, the discovery of a planet currently referred to as TOI 1075b. Although first, I wanted to briefly talk about what exactly is the mystery when it comes to these various types of terrestrial planets. So as you probably know by now, in the last decade or so, there has been a huge number of new planets discovered by various telescopes. The iconic Kepler telescope that's no longer operational is still the record holder, but the TESS telescope that's been launched a few years ago is slowly catching up. Both telescopes operate under the same principle. They look at various stars and they try to identify shadows passing in front of those stars in order to then maybe see some kind of a planet or maybe even several planets, discovering quite a lot of properties about those planets in the process. First of all, it's possible to then see the atmosphere by basically looking at the light as it passes through the atmosphere itself, but at the same time it then becomes possible to identify several other features, including for example mass and of course density of the planet, although that becomes a little bit more tricky, as I'll explain to you in a few seconds. But as more and more planets have been discovered in the last few years, the scientists started to discover various patterns, especially patterns when it comes to terrestrial planets or various types of mini Neptunes. If we were to look at planets of certain size, specifically compared to planet Earth, surprisingly there's quite a lot of so-called super-Earths, in this case planets that are at least 50% larger than planet Earth, and there are also quite a lot of mini Neptunes, planets that are at least 2.5 times the size of planet Earth. These two are given as an example. But these two types of planets were always believed to be extremely different in terms of properties. One is essentially a kind of a gas giant, so something similar to what you see right here, basically a planet that's mostly probably made out of hydrogen, helium, and maybe has some kind of a core on the inside, but is probably much smaller than the rest of the planet. But these super-Earths are believed to be more terrestrial. They might have thick atmospheres, but for the most part, these are solid planets with quite a lot of crust, with actual terrestrial properties. In other words, in theory, you could maybe walk on the surface here. And quite a lot of these planets of both types have been found in the last few years. As a matter of fact, you can see from this list, the vast majority of planets discovered are either super-Earths or mini Neptunes, with the terrestrial planets, similar to planet Earth, not actually being that common. But as you can see from this graph, there is a bit of a mystery here. It's the gap in between. Very few planets have been discovered that are approximately twice as large as planet Earth, or essentially planets in between mini Neptunes and super-Earths. And this always created a bit of a mystery, with several potential explanations offered in the past. But one of the better explanations so far essentially suggested that, well, maybe at some point, these mini Neptunes actually evolve into super-Earths by losing a huge chunk of their atmosphere. And that's possibly true for at least some of them. But it's also possible that maybe there is some kind of an in-between planet type, and it's really that type that changes into super-Earths over time. At least one of the recent papers even proposed the type of the planet this could be. They actually refer to them as helium planets. This recent paper, you can find in the description, suggests that because of various types of X-rays and ultraviolet radiation that these planets receive, over time they can actually start losing a huge chunk of their hydrogen atmosphere and actually only have helium left. And because of this preferential loss of hydrogen, they end up shrinking dramatically, but still maintain a relatively thick atmosphere of helium with at least 40% helium by mass. And this is exactly what maybe exists out there, at least in theory. And there is maybe a way to test this theory by examining one of these planets, such as the one that was just discovered right now. So here's what we know about this newly discovered planet. First of all, it's really large, and also really massive. It's nearly 10 times the mass of planet Earth, and is approximately 1.8 times larger, which makes it fit right in the middle of that unusual gap. Although here's the question, how can they possibly know the mass of this planet? It's obvious they can determine the size of the planet by measuring the size of the shadow as it passes in front of the star, but what about the mass? Well, as you probably know, various planets also influence their stars. As they orbit around the star, they end up pulling at the star, making it move just a little bit across the night skies. And this particular pull results in what's known as radial velocity. This actually can be easily measured by looking at the star and by seeing the changes in redshift and blueshift as the planet orbits around it. And by measuring these very minute changes, it then becomes possible to determine the mass, assuming that we actually know the mass of the star as well. In this case, this particular star seems to be about 60% the mass of our own Sun. And so by seeing these variations and by measuring this wobble, the scientists determined the mass to be approximately 10 masses of planet Earth. And if it's 1.8 times as large as planet Earth, this actually creates a new mystery. The mystery is density. So when it comes to average density, in the solar system, Earth is the winner. The density of Earth is about 5.5 grams per centimeter cube, and every other planet in the solar system is actually less dense. For example, Mars is 3.93, Venus is 5.24, and Mercury is about 5.43, with planet Saturn being the least dense of them all. Here the density is about 0.68, which is actually less than the density of water, which is why you might have heard that if you were to hypothetically place Saturn on the water, it would float. But I guess you would have to have a really large ocean for that. But with Earth being the densest, it actually does tell us a little bit more about the planet as well. Specifically that it does contain quite a lot of iron on the inside, which very likely causes the magnetosphere on the planet and thus improves the chances for life to exist for a very long time. But in case of this particular planet, the density was discovered to be practically twice as much as planet Earth, 9.32, which at the moment is really hard to explain. This makes it the densest super-Earth ever discovered, with this really high density suggesting that there's probably not much atmosphere first of all, but also the composition here is very different from what we expect. Specifically, it might contain some really unusual minerals and very likely a lot of really heavy metals with very high density. And because of the proximity to the parent star, it's actually very close to the parent star, it's also quite possible that here we have some kind of a magma ocean. And this could in essence produce a different type of an atmosphere. It might actually be a mixture of helium but also a lot of silicates evaporated from the surface of the planet. In other words, this planet might actually be evaporating rock because it's orbiting so close to the parent star. And as a result, some of this rock could be evaporating from the planet, leaving behind a lot of heavier metals and thus increasing the overall density. But all of this would have to be extreme. In other words, this planet will have to lose quite a lot of mass in order to actually explain this really high density. At the moment, it's still kind of difficult to explain, and it's basically one of the new mysteries to solve in some of the future studies. But there is a way for us to solve all of this, and actually really soon. James Webb Space Telescope. By observing this unique planet in the infrared light, it's going to become possible to determine everything about its atmosphere, and to also assess what sort of a surface it has as well. Is it essentially a lava planet, or is it something entirely different? And so in the next few weeks, or maybe in the next few months, we're probably going to be hearing more about this planet, and I'll definitely be following this up with a new video. Because this is just a really intriguing discovery of a planet, an extreme planet, we've never really seen before. And a planet that seems to have the highest density of any super-Earth discovered to date. And so once there's more information, I'll follow this up with the next video. Until then, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.